For low side sensing, basically we will have to do current reconstruction. So, like, how much computationally it takes, means how much it loads computationally.
Or
I haven't done it
repeat
that way.
repeat that question again for me, Deepak.
For this first case, if you see like low side sensing type current sensor, basically we'll have to do current reconstructions, no?
Yes.
So is that computationally burdenous on controller, or it's easier to implement?
So it is computationally burdensome because what you end up doing is not only you have to reconstruct your phase current, you also need to implement filtering because you have
Yeah.
significant amount of noise when you use these sensors. So you are essentially transferring your physical cost into uh, into the cost of computing your current.
Of microcontroller.
Yeah, yeah. So you need to have, I would prefer to have a DSP. I can't do that to the 8-bit microcontroller. It's going to be painful to the 8-bit microcontroller. It can be done with an 8-bit microcontroller, but you end up spending a lot of time in coding, right? So the goal should be to spend least amount of time in coding and get a product out as quickly as possible, right? So
Yeah.
we'll talk about that too. How to get a product out as quickly as possible out in the market. All right. So here is a comparison between three technologies. Uh, sorry, Deepak, I didn't mean to cut you short. Is there any other question regarding the sensors? Okay. All right. So in terms of comparing three technologies, shunt, Hall sensor, and CTs, obviously we don't need to use the transformer part because only AC, so we don't really consider this. Between shunt and Hall sensor, good accuracy, cost obviously is low for the shunt. Isolation, you have none here. DC offset problem, yes. And saturation, no.